Okay, welcome back everybody. Our next talk will be about VM backup beyond Bacula, presented by Christian Theune. Enjoy.
Thank you. All right, I hope you all had a good lunch break, and instead of being like well-fed and very sleepy, you're all excited and very wide awake now. The first thing I'd like to say is I'm really sorry this talk is kind of a little bit later than expected because originally it should have been last year. And last year I boarded the wrong train and I went to Nuremberg. And I noticed while finishing my slides that the logo was always saying like Cologne. It's like, why did they put Cologne on the logo? I'm going to Nuremberg, and then I noticed, like, God damn it. Looks like I made it this year, and I'm happy that I got a second chance. I didn't even have to fill out the form anymore. They just took the one from last year, but I almost missed it again because my son-to-be, who's due in about 4 weeks, decided to give us a first sign-off. He might come around on Sunday. So yesterday I was busy on trying to arrange whether I can come here or not. Okay, so I'm not a dad yet. I'm very, very relaxed. I can give this talk. All right, backup. I've been doing backup since ages, like 98, 99, of servers, workstations, applications, databases, file systems, whatever, and it's always been painful. It's always painful. And I remember that back in '99 we used a Tandberg drive with Amanda or something. I think it was Amanda, and there's something like Zmanda back then. And we moved on, and we got a small tape library with multiple tapes. And whenever we stumbled into any kind of issue that was like hardware related or what we chose to use, one of the answers of vendors would always be like, yeah, you have to spend more money. And that is like my first response to you have to spend more money is, okay, I'm going to use a different vendor, because why did you sell me something in the first place where you tell me it doesn't work, I have to spend more money? No. Today I work for a company called the Flying Circus. I'm a co-founder, and we operate custom web applications. We have a public cluster, but we run private clusters too, and we manage a couple of dozen, like maybe 40, 50 physical servers, and actually a couple hundred, 400, 450 virtual machines. And the sizes of these machines, they vary a lot, and the workload varies a lot. And we've been using Bacula for a long time, like 5 or 6 years on this setup, and we've been using Bacula before. And we always used like a RAID 6 array. We never really used tapes there. This is going to be a recurring theme. We use Ceph as our primary storage for the virtual machine disks. We used to use iSCSI, and when Ceph became stable enough, we moved over there, and we've been pretty happy. And up until now, we've been taking backups directly from the Ceph storage servers. And the file daemons don't run inside the VM. They run on the backup server, actually, that accesses the Ceph RBD volumes from a snapshot and not inside the VM. We run a file descriptor in the VMs at the moment to restore into the VM. But that is actually one of the complexities I'm going to ramble about. And we also have some pre-post scripting for triggering snapshots and setting databases into backup mode and stuff like that. This talk is mostly going to be an excursion into, okay, so why the hell did you abandon Bacula, something really big and proven, and build your own thing? And all of the things that I'm going to say are perpetual work. It's like everything's in progress. But at the moment, we feel that build your own, for our case, ends up with higher quality and less maintenance than we had with Bacula. Whether that's true in the long run, we'll see. I don't know. I mean, everything's changing all the time. Maybe in 5 years we go back to something pre-built, but at the moment we didn't find anything. So let's start with the question of why did we get to the point where we asked how can we get away from Bacula? Part 1, the pain. All the tools always have nice things, bad things. You have a rough time, you're in love with the tool, and then you get in a big fight. And the issue is Bacula has been on our naughty list for quite a while, and I'm going to go to that one incident that spilled over the bucket and that caused us to take action. So we had a relatively slow day, and this is in March last year. It was a pretty slow day. Everybody was just working on their things, and suddenly Nagios would start giving us alerts about file system errors in the virtual machines. First one, second one, 3, 5, 10, 50, 100, and we're like, okay, fuck, something's wrong. So it's not such a slow day anymore, and this is about like 10 minutes to 3 in the afternoon. We pretty quickly found a quite complex bug that caused a rogue Ceph server that was not supposed to be part of our storage cluster anymore, that we teared down and moved over to a customer's installation. It reconnected to our main cluster, and for a very complicated reason, both the cluster and the server still had the credentials there. That shouldn't have happened, but accidents happen. And it triggered deletions for all the pools. And I think we lost about 50% of all the virtual machines that we were running in production at that point. And it was only 50% because the deletion commands came in so fast to Ceph that Ceph was kind of overloaded. It didn't manage to actually delete things. Like, okay, these things happen. That's what we have backup for. So we go ahead and we restore, right? About 1.5 hours later, we fixed the bug and we disabled all the code in our instrumentation that actually starts deleting things. And we started restore. Because this is a very big thing, like 200, 300 machines, you've got to decide where you're going to start. You have a couple of customers with an SLA and they need to be prioritized. You have a couple of central services like monitoring or mail server or stuff like that that you also want to get going initially so that you can communicate with the customers, etc. And we started that, and things felt quite smooth. However, if anybody of you can read like the gray things there, 11 hours later, we were pretty much done from the number of machines that we had to restore, but we were already also quite exhausted. It's like, okay, it's taking 11 hours to restore that. And the one big thing that was missing was our most valuable customer's database VM. It just didn't want to restore. We were already on a multi-shift cycle, 3 people that were overlapping, taking pauses, going to sleep, coming back. But Bacula was hitting a limit where either we could continue restoring smaller VMs or try to figure out why this one big VM was inconsistent. And it always ended up failing around the 70 gigabyte mark. And it's like, okay, I can't do this, and it stops. And when we try to fiddle around and change director settings, we had to restart the job from the beginning. It would run another hour or and a half to tell me, yeah, I can't restore that, it's inconsistent. I'm like, God damn the inconsistency, just keep running. And whenever we had to fiddle with that, we also had to stop the jobs that were restoring in parallel. So that was getting on our nerves. And overall, about 20 hours later, we had all the customer services back online. There was almost a day. Our most valuable customer had the most downtime, even though we spent a lot of manpower on it. And that was just like, okay, this is screwed. This does not work. We can't live with that any longer. And we sat down and we tried to figure out what's the root of all evil. And it's not a single thing. It's actually a pretty long list of small things, medium-sized things, maybe a couple of big ones. And if you want to get all the details, you're going to find the slides online, and there's this link, and this is the PDF of our 8-page document that says in detail what happened, when did we do what, and what are the findings that stopped us doing things, how did we fail in the first place, and what is in our way. And Bacula is a big thing there. The first thing that failed us was our restore script. Turns out this script has evolved over time, where we can say, okay, here's a script, you go to the backup server, give the name of the virtual machine, and it's going to do a full restore. It recreates the image in Ceph, it figures out what was the last successful job, instructs the director to restore, etc., etc. The problem was we noticed after it evolved, we had a global lock where this script could only run once at a time. So we had to sit down and look through the script, and a big part was that we had to instruct the director in a way that was kind of hard. And it took us about 3 hours to get this lock go away so we could then start ramping up parallel restores. This undetected inconsistency that stopped to restore the biggest VM, that was just insane. having to sit down and see, okay, yes, there's like 1 byte inconsistent in the middle, and then trying to figure out, and the manual wasn't helpful, and internet wasn't helpful, Stack Overflow, server fault wasn't helpful. It took us ages until we got like, for this special case, the just right knobs turned for the director to actually ignore this inconsistency and continue. And there was actually around the clock one person of our team just looking into this one issue. And also every now and then we had to stop all the other backups to try out whether we actually fixed the issue. One thing in the aftermath, when we restored, when we got around this global lock thing, we noticed that instrumentation around Bacula is also kind of complicated because of the virtual tape library. The virtual tape library concept is from the time when we used to do tape backups, which we don't do, so we're getting additional complexity. Where does the actual data end up? And it's like, we've got all these virtual machine images, and they end up in actual files that emulate to be virtual tape drives that behave like, okay, I'm going to intermingle different data from different customers every 2 megabytes, stuff like that. It's like, what? Why? I don't think that we're ever going to get to the point where scripts that you write are going to be perfect for all the situations to run into. It's always going to have like this one thing that's going to break your neck, and any complexity that you don't actually need is going to increase the chance that you're going to hit something that you can't remedy at that point. It's 3 a.m. in the morning, you're already blind drunk, you're on duty, and you have to fix something. So I really wish the scripting stuff and all these small moving parts would be much, much simpler. At some point, we decided that we don't have to back up everything because most of our customers have like the same virtual machine 10, 20 times because they're just application server instances that don't have any local data. So we just back up like 2 or 3 of them. And for the others, we say, hey, we've got automatic deployments. We just rebuild the VMs when we need them. The problem was, obviously, that kind of rebuilding also didn't work quite that way under disaster recovery conditions as you imagined when you're in normal operations. So we were already loaded with actually fixing our restore, where we also had to fix automatic deployment stuff that wasn't quite as usual. And why did we not back up everything? Obviously, we thought we could get away with getting some load off the Bacula server and save disk space. I mean, who doesn't want that? Another thing we noticed was 24-hour backup cycle is not a sufficient RPO, a recovery point objective, like how far do you have to travel in time back to get a consistent data set back. Most cases, daily backups are okay, but in quite a few others are not. For example, mail servers, honestly, your customers care about all the data within the last 24 hours and not before. So you're actually, if you're on a daily cycle, you're actually backing up all the stuff your customers don't actually worry about. And we'd actually like to give customers the option for hourly backups, or maybe every minute, or something like that. With Bacula, we didn't see any feasible way to do that because the whole scheduling, the amount of jobs we were running and stuff like that, it just didn't fit any longer. Also, we have a couple of pathological cases where the applications have append-only files that grow very large, like 100 gigabytes, 200 gigabytes. And if nothing has happened in the universe in the last 12 months, and please, if anybody figures that Bacula changed in between in a way that I'm completely stupid and just using it wrong, tell me later, publicly. But append-only databases, you always get a fresh copy every time. You've got a differential or incremental, and every time you change 2 bytes and you get a 100 gigabyte copy again. Great. And this is just insane write amplification. And then there's this list of paper cuts. Yes, we're still running Cyrus because we didn't get around to replace it with something better. But still, we've always had, whenever we had to restore this virtual machine running Cyrus, we ran into some bugs where you had to restore hardlink farms where Bacula just missed a couple of them, and your Cyrus is just not even noticing and just doing random things. I hate that. And that actually made us think is, okay, so Bacula is rebuilding, and building a new format, an archive format, that has to replicate all the logic that file systems with ACLs and extended attributes and everything else, it has to get right under the semantics of differentials and all kinds of other abstractions that are in there. Too complicated. We were missing bootloaders because with Bucky, from the images, we were taking file level backups, right? That's what Bacula is for. But that means that when we rebootstrap a virtual machine, we have to first create an empty machine with a file system that has the bootloaders in there, store the data back in, and then run group or something similar. And something we notice is that you can get to the point where your automation changes how the bootloader works in your environment, and you restore an older version into the new version, because a few days earlier we actually had a change in how our bootloader was configured. So a couple of the VMs would actually not start correctly with the restore VM script because the way it was setting up the bootloader wasn't compatible with what's in the backup. Great. And overall, the director is a single process for hundreds of jobs, and you can't reload it on the fly. You have to stop and start it if you make a change to the configuration, which in our case, the text files of the configuration, and we are making use of all the templating stuff and not like generating things too much. It's still 2 megabytes of text files for Bacula configuration, honestly. And I can never predict how schedules will work out. I have no idea. Like you make rules, and at some point a customer asks you, and you're like, that didn't quite work that way. Okay, so we had a fiddly script. We had an inconsistency that it took us 20 hours to get right. We had blind spots that we didn't back up correctly, like the bootloader. The daily interval was killing us, and the overall complexity, and whenever we change something, predicting how it's going to work out. And all these paper cuts when it's 3 or 4 a.m. in the morning and you already had a regular shift and you're on your second night shift, and it's just like, I want to make a wish. Part 2. Okay, I want everything to be much more simpler for our case. Restore, if I can make a wish, works without anything that has anything to do with the backup tool. Restore should work from a mostly no config needed live booted Linux distribution like DD. DD the disk image from here to there and then start it, something like that. I don't want complexity like the virtual tape library. I don't want to even, I think I forgot to write this down here. I don't even want to deal with files. I just want to deal with this big, huge image. It's an image. There's something in there. I don't care. And I don't want to mix data of different VMs. I don't want to have a file on the file system where there's data of multiple VMs in there. I just don't want that any longer. Reliability-wise, I want something with better verification, scrubbing, repair maybe. I would have loved if Bacula could have given us a heads up of, hey, you've got bit rot and you won't be able to restore what you had today. The problem there is, I think there is an option around that, but bandwidth-wise and storage I/O-wise, that's just not possible to run for us for all the time because it doubles the amount of work we have to do to take the backups. I want much higher frequency. I want a more direct integration with how do you create snapshots with the backend. The way to do pre-post scripts at the moment is like, you can't really signal many special situations of, okay, should you retry this, or should you do this, or should you do that? And we've got this huge chain of, you have one job that is the precondition of another one, and a precondition of another one, and a precondition of another, and one post job, and a post job. So actually, if you look at our list of jobs that the director runs, all these pre-post jobs, for a single job, you have like 6 entries. It just explodes. I don't want to invent new formats. Everything I have to invent new is going to break. So let's not invent new things as good as we can. I want to avoid bottlenecks. I don't want to get head of line blocking. I don't want to, like, when you have a big job restoring at the moment or backing up at the moment and you want to restore and you're at your limit of how many jobs did you configure to run in parallel, you have to wait for that to end. It's like, okay, I can either stop the backup for this customer to restore that customer right now, or reconfigure, which also means to I want to be able to parallelize this much easier, to just have like 2 or 3 machines that don't know anything of each other, that back up different parts of our infrastructure. Scripting should be much simpler. Environment-specific configuration, integration should be much simpler. And this whole coordination thing, like, okay, you're taking a backup of this disk image, and you have to talk to the storage layer and the hypervisor and the VM in there. It's like coordinating stuff like that should be much less fiddly. Wish list, the last thing of wish list is getting pretty long. I want a much more straightforward integration with Nagios to ensure that we are able to hit our recovery point objectives. Like, is everything new enough? And are we going to kill any SLAs that we have with our customer? And also, on a mass restore, I want to be able to figure out whether I'm compliant towards the time I target to be done with the restore. And maybe even self-service for customers where you have a shared environment. Okay, let's do this. How would this look like? The first thing that I'd like to talk about is size. And I think somebody probably said one size fits all. Not. Bacula and Barreos are general solutions to a really big problem of backing up and restoring data. They've got advanced capabilities, they've got a large installed base, they support many features, contributions look very stable, awesome. But again, the complexity is what gives us the pain. And I want to drive down complexity as far as I can. I want to build on existing tools and then maybe add a little bit of our own. So what I'm going to present is not backup for each and every one. It's backup for us and how we figure out, like, where should we spend our time to end up with something that's reliable and operatable. Right. Talking about size, Bucky, that's the name of the open source project we started and that we're using, this is slug count, like one of the worst ways to measure complexity or size, but still. Bucky at the moment, as we are moving it towards production, and we've been running it partially in production for a couple of months, is about 3,000 lines of code in Python. And about 50% of this code, so about 1,500 lines, I think maybe even 60, there's a couple of files in there that slug count miscounted, are tests. So it's only about 1,500 lines of code that actually do backup. And the coverage analysis tells me that we have about 94% of branch coverage in the code. Like, almost every part of the code is actually executed in tests that run in, like, I think the overall time is 2 minutes. I can run the whole test suite for everything in 2 minutes. I make a change, I run that. We've got a server running online that does that all the time, so we don't have. So we see whether it runs not only on the developer's machine. If I compare that to Bacula or Barreos, Bacula has about 150,000 lines of code in C. That's about 50 times the size. And if I consider intellectual complexity, I think that raises geometrically. This isn't n, this is n squared. So that means that it would be about 2,500 times more complicated. Obviously, I'm making that number up, but still, I need irony to deal with all that. It is a lot of code, and I tried to figure out whether there's any automated tests. Is there anybody in here who can tell me that there are automated tests, like unit tests or functional tests, integration tests that run for Bacula or Barreos? Yes.
There's a complete test to run integration tests.
Awesome. Why didn't I find that?
You didn't look right.
Okay. I need new glasses. Okay, so what I found, I just grabbed around through the code base. So it's not part of the main repository, right?
Yes, it is.
Okay. I grabbed through both of them using a simple find grep test, and then whether that's a directory or file, pass that to slug count. For Bacula, I found 1,500 lines of code that maybe are tests. It's about 2%. Barreos apparently is better there. They look really good from a project perspective. They grew the code base by 100,000 more lines of code. So you've got active contribution. That's awesome. when there's an active open source project, thumbs up. It's all good. And my insanely dumb test script to figure out how many tests are there showed me there's 5.5 thousand lines of test code. Could that be right? Would that be wrong? You don't know. Okay. The good news is you've got, from my numbers, you've got 0.2% more coverage. Okay, so I would love to see, if you can afterwards point me out or Twitter where these tests are, I would love to see them. Okay, so size. Everything's much smaller, but it's smaller because we chose to use specific tools that we built on that do specific parts that we don't have to do. First, we're reducing the problem space, right? The only thing I'm going to back up are QEMU virtual machine images. So part of the job that we're doing is already done by QEMU because they have a couple of APIs like fsfreeze to talk to the Linux kernel to make things consistent on a mounted file system, stuff like that. All our disk images are stored in Ceph, and Ceph has cheap snapshots. Even the ability to give us cheap deltas. I can make 2 snapshots in Ceph of a disk image, and I can ask it, please give me a space-efficient delta of what has changed between A and B. And we're also using btrfs as the target system to store these images as plain files, where we use copy and write from the last snapshot to the new snapshot. Then we get the delta from Ceph, and we just integrate that delta into the file. So basically, we've got image files sitting there that are byte-exact copies of the disk image in Ceph. So we just have to DD this thing. I can run stuff like kport or loopback mounts on these things if I really want to touch them, but I don't need my backup utility to access the backed up data, and that was one of the big things. Limits. I can only drive down complexity by limiting what I want to do. It's not a general purpose backup system. We don't do weird hardware. We don't do tapes. We explicitly said we want to restore without tools, and also we wanted to have the configuration much more simple. So our current target is that we have in our shared environment a single server with 50 terabyte of space in a RAID 6 with hot spare and stuff, and the only thing I want to do is get data out of Ceph and get data back into Ceph. All right, let's take a tour. There's 4 things involved at the moment, and the only thing that's Bucky are these 2 things. These are processes. We've got a server called the Bucky daemon, and what it does is it regularly starts other processes, like small jobs, that make one specific backup for one virtual machine. And the point is these are separate in a way that the only thing the daemon does is start them regularly. I can always go ahead and just call this command directly. There's no under the hood things going on there. And the backup consists of the following workflow. The job itself requests snapshot by writing a specific key into console, which we use for distributed events and inventory management. And console informs an agent running on a QEMU KVM server that we want to have a snapshot of a specific virtual machine. That agent talks to the QEMU process. The QEMU process triggers fsfreeze in the Linux kernel inside. Then it takes a snapshot, does the unfreeze. The snapshot then is stored in Ceph, and the Bucky job notices when the snapshot comes into life, calls rbd-diff, and stores that into a btrfs file. That's it. Still, you might argue there's lots of moving parts there. Yes, it is. And it's still quite complicated, and it's still quite involved. But the point here is all of the tools like Ceph and QEMU and console, they exist not just for backup. We manage them and use them anyway for multi-purpose stuff. All these parts, they just contribute to us being able to do smooth backups. We use QEMU anyway. We use this agent, the FC agent, anyway. We use Ceph anyway. in that sense, the environment is very Unix-oriented. We're trying to use composable tools that have very specific jobs that can be used for multiple different tasks. So we invest in running a nice console cluster, a nice Ceph cluster, and into running QEMU right, and then we just want to go ahead and say, and this is what we spend to do backup for that. Overall, I found that plugging these things together and testing them with a little bit of Python code, like 1,500 lines, and treating that not as, oh, this is an admin who runs a shell script, but this is software development, of course, and we've got to run tests on it, and we've got to do quality assurance. Tying that together feels much more straightforward and intellectually less challenging than trying to figure out the right Bacula configuration for us. And we realized that we have stopped shopping for one-stop solution tools that do like everything. We don't want a cooking oven, microwave, TV, lawnmower. We want sandpaper and a hammer and nails and electricity, and then we want to build something that we know how it works because we have to debug and take it apart in the middle of the night. So here's how it looks like. It's a small Unix shell utility. This is what -help looks like. It uses the typical subcommand style. You might know that from Puppet or other tools. And intentionally, on a daily basis, you will never have to touch that. Calling that is basically optional in the times of need. One thing I'm going to show you first is the thing that you're never going to use usually is how to do a backup. So this is how you do backup. There's a directory. Lidprod00 is a directory. That's a working directory right now. Lidprod00 is the name of a virtual machine in our environment. And I run Bucky -v for actually having you to something appears that I can show to you. And I tell it, make a backup, and give it the tag test. And it goes ahead and it says, okay, I'm going to make a new revision, and I'm going to requesting a snapshot, and I'm going to make the differential backup, partial verification, and says everything's okay. And it took about 8 seconds to back up a 10 gigabyte volume. And there's two pieces in there that are slow. One is Ceph takes a little bit of time to compute the delta, and we take extra time to make a partial verification of verifying that the delta was integrated in a way that it reflects the original source. So we just take like 3 or 4% of the source images and the backup file and just take random blocks and compare them. There's a utility you can use for looking at the status. So each backup, we call that a revision. And you can see that it has tags, and tags are things like daily, weekly, monthly, or test. It's got a UUID, short UUID, so that it can be put into URLs if needed. And we store a little bit of statistics, like nothing really important there, nothing exciting. But you can also inspect a backup by just going to that directory and run ls. So as we decided we didn't want to mingle data of different VMs, we came up with, okay, let's have a master directory where the btrfs volume starts, but this is not even tied into Bucky, it's just like how we use it. And the daemon can then create one directory per VM that we back up, and within that directory, all the data of that related to that virtual machine will show up. So the logging output of Bucky related to that virtual machine sits in a log file in that directory. Every revision has like one big file. Where is it? Like 10 gigabyte. That is the actual data, and a short YAML file with some metadata. And if you're looking for the last backup of this thing, there's a symlink that is automatically maintained. So in the middle of the night, I can go there, I can take that file, I can DD it somewhere else, and I'll be happy. And the log actually contains all the output of all Bucky commands that you run for that VM. Even if I run Bucky status or something else is around the daemon, it will always write stuff into that file so you can see that an admin was there and actually did manual things. We have a daemon, very simple thing. Originally, I didn't even want to have a daemon, but figuring out how to do load management to make sure that not all 400 virtual machines try to back up their volume at the same time, we decided to not just create a cron job for all of them. So it's a small daemon. It has a couple of small clever tricks to keep config simple but also smart. And I'm actually pretty happy, just if anybody of you should be programming this kind of stuff, Python 3.4 and async IO are really awesome for this kind of stuff because it has low overhead, and we just start a coroutine which has a very small memory overhead that has an infinite loop that is easy to read that says, figure out for this virtual machine, so every virtual machine gets its own loop, figure out the next time to do a backup, wait for it, do it, figure out the next backup, wait for it, do it, and this kind, the whole code is like maybe 200, 300 lines of code for the scheduling thing, and it's really easy to test and really easy to think about. So yeah, quite happy with that. Also, this scheduler is completely stateless. There's no database, nothing. At any point in time, you can kill it, start it again, and it's gonna figure out the exact same times when the next backup was due. It's going to catch up stuff that it missed. There's no queue that you can lose. Nothing. Also, again, the schedule is completely irrelevant to restoring. While it's taking backups, you can do restores. Doesn't care. You can stop it if you want to like reduce load or something like that, but you don't need it. This is what configuration looks like. You've got 3 sections. There's a global option thing where you can say, okay, how many jobs should the scheduler start at the same time? Where does the base directory go? It defines schedules. I'm going to talk about the schedules in a second. And it defines jobs. And a job config is really just, this is the name of the job, this is the type of the source, and we've got 3 simple things. It's a general copy those files over, then a generic take backups from Ceph, and a plugin that we wrote on top of that for take a Ceph snapshot in the way that this diagram was showing that is specific to the Flying Circus. And then it gets a parameter, the virtual machine name maybe, if it's our environment, and which schedule it should adhere to. And one thing on the scheduling is it only references that schedule's name, and automatically based on the name of the job, it does an offset, a modulo offset, like if you know Puppet, FQDN, Rand, like you do for distributing cron jobs, that what means daily is different for each job. So scheduling is a 3-level thing. You have a schedule that gets a name. A schedule has tags, and each tag has an interval and a keep. We never keep references to absolute times. They don't make sense on a broad platform like ours. We have to adjust backups in a way that doesn't make sense. We've got customers in different time zones, and they've got different load profiles. And honestly, I just want backups to be so low impact that I just keep running them and distribute them all over the day. There's no logic for like referencing weekdays or holidays or whatever. It's a predictable pattern of every tag says I want to run every 24 hours or every 7 days or stuff like that, and I want to keep it 9 times or 5 times. That's it. And when Bucky runs a backup, you saw that at the command, it simply says make a backup and put that tag on it. That's it. And this is what it looks like later on if you look at the status thing. You see like there's hourlies and dailies, daily weeklies, and it always gets exactly the same time. It's like it catches up those seconds perfectly, so you can see, hey, everything's beautiful. It's always the same time. This isn't really important under stress, but during regular times, it's quite nice to see that everything's on schedule. We also don't differentiate full and differential or deltas. If we don't have a base image, or if the snapshot in Ceph is missing, we just make a full copy. If we have a snapshot, we use rbddiff, and then we integrate it, and we keep verifying it. That's it. Nothing to configure. Purging. How do we get rid of stuff? Well, as the slide says, there's nothing to see there. Almost. So purging is the backside of the schedule. It's the other end, the keep value. And the keep value means two things. First, don't remove this tag from a revision as long as we have n revision, less than n revisions with this tag. If I want to keep 7 dailies, then it will never take away a daily tag from a revision if there's less than 7 daily tags around. And the second thing it means is don't remove this tag from revisions as long as the oldest revision is still younger than interval times n. So if I want to keep a daily 7 times, and daily means 24 hours, it means first you have to have 7, and the oldest one has to be older than 7 times 24 hours. And then when a given tag runs out of that, it gets removed, and when a revision doesn't have any tags any longer, we just delete it, which means RM. Scrubbing. Well, 3 levels. During a backup, we do a percentage-based, like 2, 3, 4, 5% comparison between original and target, randomly. So over time, like over 10, 20 backups, you get a full verification for free. btrfs scrubbing, obviously, can tell us whether something's going wrong, and we're running rate 6 under that. I feel pretty safe with that at the moment. Maybe we're going to have another disaster where I come back and say, this is shit too. How do I get rid of a VM? And the point here is that if a customer says, I don't want the VM anymore, I also don't want it to stick the backup data around for infinite time. And I don't want to do complicated stuff. So what do? Automation rewrites the config, reloads the master, and then we do rm-rf. End of story. How do we monitor this? Was also a big point. I'm kind of proud here because we tried multiple things to back up, to monitor Bacula in the past, and it always got a little bit too complicated, like make stemp files of when was the last full and the last this job and when did these things happen. And it was always brittle and didn't trigger at the right times, or due to delays, our age computation was wrong. And actually, I want to have a single test that tells me in the morning, dear admin, do you have to do something or don't you have to do something? And here's what I built. There's a simple telnet console. You can telnet into Bucky, and it gives you an overview of what's going on. And the SLA column is what's interesting. And SLA means the last backup is not older than 150% of the interval time of the smallest interval. So if you do an hourly, then the oldest backup shouldn't be older than 1.5 hours. And that's everything I check for. Bucky has a small subcommand check that aggregates that for all VMs and conforms to the Nagios plugin API, and the scheduler dumps its status every 30 seconds into a static file, so the check can actually look at the file and not talk to the daemon, and that's it. That's really simple. Also, the most important part here is I don't care about history. I don't care about any old backups. If I failed a backup last week, I don't want to see that in monitoring any longer because I can't change that. Last week's done. I always want to see, are we good at the moment? Okay, so that was a fast tour. I hope you don't feel like that kid. Let's wrap it up. What did we leave out? Physical host backup. I don't really care about backing up physical hosts that much because they are automated on the installation anyway. But important stuff because you do have one-offs here and there. We rsync them into a virtual machine and then we put that into Bucky. That's it. Also, I don't really care much about backup storage ratio at the moment. Obviously, storing 100% every day or every hour for 3 months is not feasible. Storing maybe 2 to 4 times original volume, that's fine. Probably even 10 times. Space is cheap compared to that. I'd rather have all the other parts done right. For the future, what we're currently working on, trim ready. So Bacula is happy to do sparse files, sparse images. The whole stack of the VM side, the guest kernel, and the guest file system, and the hypervisor and Ceph, we still need to tune that to actually pass the trim through so that volumes will actually shrink if the customer deletes data. We currently don't do hot reload, which isn't that important to us because we can kill and restart the scheduler without any negative effects. And something I would really love to see, and I have to play with btrfs for that, is whether we can export the whole copy and write data structures of one directory from a backup server to another backup server without too much hassle. All right. So the biggest thing I wanted to get off my chest here is Bacula has been good to us for a long time. It's always been a little bit annoying when it came to restore, and obviously we all know nobody wants backup, everybody wants restore, but that is where we had the biggest pain, and that's why we set out to figure out whether we can do something different and where would we end up. And I think we have grown out of Bacula from two perspectives. The amount of data at some points is just too slow. And it feels like that's overhead, like trying to select files from a large file system with 200, 300 gigabytes and lots of small files. Computing that over like 4 diffs sometimes takes 10 minutes, 15 minutes, and you can see that Postgres is running insanely on the CPU and a disk. And we need to move faster, we need to integrate more closely with our environment, and we want to solve policy-oriented stuff on a completely different level than trying to script a static API like we have here with Bacula. All of that is my personal experience. I love knowing how the individual pieces work, and that is something that Bacula doesn't do very well for me because it's so big. And we're happy to contribute our experiments. If you want to try it out and look at it and have some ideas, I would love to see more experimentation. I think small is beautiful. I might be completely wrong. I might say the opposite thing tomorrow. So customer beware. I'm a minute overdue, so I'm not sure whether we have time for questions, but thanks for having me.
Thank you. Are there any questions?
Did you ensure in any way before that backup method with the VM snapshot that the file system backup was consistent before? So before you had the crash?
The file system backup?
Yeah, of example, did you use backup agents for MySQL databases or something like that?
We did run FSCK on the read-only file system. I think we weren't able to use fsfreeze before. So I think what we did was run a sync and then run an FSCK to figure out whether it's completely broken or not. So not perfectly. We had a couple of tripwires, like we take the Ceph snapshot. On the snapshot, we run FSCK, and then we had a small script that goes through and says, like, okay, this is okay or not.
Okay, thanks.
We're doing that now, right? With the QEMU integration, fsfreeze, that gives you a guarantee that the file system's clean. I think QEMU has a couple of bugs here and there. I think the freeze doesn't flush all the buffers, but overall, I keep poking at it. I see pretty clean file systems over time, even with the diff integration.
The Bucky, is that open source?
Obviously it is, yes. Sorry for not being more explicit on that. I think it's a BSD license or maybe GPL. I inherited a little bit of code from a friend in Ulm who was doing something similar but different. And he gave it to me to open source that and then work on that. And it might be that he has required GPL on it.
Okay, nice.
Really, personally, open source is the default. I only close source any of my code if somebody beats me, and he's got to beat me with money. Any other questions? Otherwise, I'll be around for not that long anymore not because of my child, but more places to go to.
Okay, thank you.
Thank you.